This video is to allow you to correct your answers for section 3.2.1. First of all, in the methods and meanings, they remind you that an algebraic expression consists of one or more variables. So a numerical expression is just numbers, but if it has one or more variables, we call it an algebraic expression. And again, there's a combination of numbers, variables connected by mathematical operations. So 4x would be considered a algebraic expression, means 4 times the value of x. 3 times the quantity x minus 5 is an algebraic expression, and so is 4x minus 3y plus 7. If you're asked to evaluate an algebraic expression, you're going to replace the variables with their numerical values and simplify, meaning find the answer. So when we replace variables with their known values, we call it substitution, and they give you an example. So if we're asked to evaluate 4x minus 3y plus 7 with x being equal to 2 and y being equal to 1, we replace x and y with the values of 2 and 1, and then find the answer. So evaluate means to find the value. So what they did is 4x became 4 times the value of x, which is 2, minus 3y became 3 times the value of y, which is 1, and then plus 7. And so then they just went ahead and followed order of operations, finding the answer. So for 334, the number 6 is represented with positive and negative tiles as shown. They want you to start with this diagram for each one and then show how to remove the appropriate number of tiles to represent the problem given. So this is a value of 6 because it has 3 zero pairs and 6 positives are left. Okay. Now, what they want you to see is that we can take this value of 6 and we can subtract away 7. Now, if it doesn't have a sign, when we're subtracting it, we're subtracting positive values. So we're subtracting 7 positive values. Well, if we take away 7 positive values, 1, 2, 3, 4, 5, 6, 7, now we can make only 2 zero pairs, and we still have that 1 negative left. So our value would be -1. So you're removing the 7 positive tiles, and you're getting a value of -1. Again, make sure you're showing that as well. Here, we're taking 6 and subtracting -2. Again, this is the starting value of 6. If we take away -2, that means we can only make 1 zero pair. And so now we're going to have a value of 8 left. And then 6 minus 3. All right, so make sure again that you're showing that in your doc. Here they want you to use a number line to show the distance between the integers. Plot them as a point on the number line, find the distance between them. They want you to write it as a subtraction problem using absolute value symbols. So like for the first one, 7 and 4, you would make a number line. You'd put in a value of 4 on your number line, 5, 6, and 7. And you want to find the distance between these. Well, the way to find the distance between two values is to find the difference between those values. So it's the absolute value of 7 minus 4. Or you could actually make it the absolute value of 4 minus 7. It's just finding the difference between these two values. And we know that absolute value will always be positive because it represents distance. So either way, your answer is 3. Same thing here. Put it on a number line. And then you're taking 5 minus the -2, or the -2 minus the 5. Either way, you should find a distance or difference of 7. And the same thing here. So again, make sure that you are showing it on the number line. Make sure that you are writing it with absolute values, although it doesn't have to be both ways, just one is fine, and then what the distance is. Here they want you to consider this expression. So first they want you to draw it using positive and negative tiles. So for my positive 5, I would put 5 positive tiles right there. Okay. Then I'm adding 4, so I put those down there. So here's my 5 plus my 4. And then I need 2 groups of -3. Well, 2 groups of -3 means 2 sets of those. And then I'm adding 7, which is here. And then I'm adding -5. Okay. So this would be the idea of drawing it. 5 plus 4 plus 2 groups of -3 plus 7 plus -5. Then they want you to simplify it. In other words, find the value. Again, my suggestion would be to make your 0 pairs. So, these 5 positives could simplify with 5 of the negatives here. We could simplify a positive here with a negative here. We could simplify, let's see, we've got 5 negatives here, so we can simplify with 5 of the positives. So what are we left with? Well, we're left with 3 positives here and 2 positives here. So a total value of 5. And again, you could draw yours any way you wish as long as it shows that. Now they want you to remove the last number from that expression, that -5, and find the sum again. So what you'd be doing here is you would no longer have this. You would no longer have those -5. Okay. So what ends up happening is now you're going to go ahead and show, again, your 0 pairs. Here's 5 positives with 5 negatives. Here's 1 positive with a negative. And then everything else is left is positive. It's a total of 10 positives. And so by removing your negative, you actually made the sum 5, or a value of 5 larger. You made the total 5 larger by removing a negative. Again, we talked about the math notes. You may want to reread these, but we want you to look at the way they have shown the tightrope here, and to think about how you could represent the lengths of the tightropes based on what they're giving you. So Jorge wrote this expression, x plus x plus x plus x plus 3. Does that make sense? Okay. Yes, it should make sense. Now your explanation might be, we're adding together values that are all the same, calling them x, we don't know their values, and then we're adding 3 units at the end. And then how could you represent this sequence? Well, we have j plus k plus k plus k. So you could write it that way. You could also combine and say we have 2 j's plus 3 k's. So 2j plus 3k. And then if we go back to that first one of x plus x plus x plus x, I think I said 4 of them, plus 3, and if x is 5, how long would it be? Well, what that means is this is now 5 plus 5 plus 5 plus 5 plus the 3. Okay, so it'll be 23 feet. You may want to show how you got that 5 plus 5 plus 5 plus 5 plus 3. And then in part B, if j is 3 feet and k is 2 feet, how long is that? Well, j plus j would then be 3 plus 3 plus k plus k plus k would be 2 plus 2 plus 2, giving us a total of 12 feet. So again, show a little more work here than even what I have. And then here you have to simplify them. Again, you need to show all your work. So make sure you're showing how you're getting like a common denominator and so forth. Now, I'm not going to show the work for all of them, but let's just look at A. So we have 3/4 plus 2/3. So what you want to do is look at the denominators and figure out what is the least common multiple of those denominators. So what is the smallest multiple of 4 and 3? All right? And that, of course, is 12. So we're going to be converting them both to 12ths. Okay. So I should see this kind of work. Then you are going to say to yourself, what do I multiply 4 by to give me 12, which is 3. If 3 is the bottom number of my giant 1, it must be the top number of my giant 1. So I end up getting 9/12. And looking for your giant 1 here, 3 times what equals 12? Well, that would be 4. And then if 4 is the bottom number of your giant 1, it needs to be the top number. So you get 8/12. So we're taking 9/12 plus 8/12. Well, that's 17/12. But the other part of the work you should show is how, what is 17/12 as a mixed number, which is 1 and 5/12. Now, you could do that in your head, so I wouldn't need to see that work, or you could show it. But certainly this work needs to be shown. Here, you should change them both to ace. 7 ace minus 2 ace gives you 5 ace. Here, you are multiplying. Remember, when we're multiplying fractions, we do not need a common denominator. So you are just going to multiply across and get 3/15, which would then simplify to 1/5, divided in both by 3. Or you could simplify before you multiply. The 3's in the numerator, the 3 in the numerator, the 3 in the denominator will both divide by 3, giving you 1 and 1. 1 times 1 is 1. 5 times 1 is 5. So I want to see either what you got initially and what it simplified to, or that you simplified from the beginning. Now with this one, same thing, you're multiplying, so you do not need to show your common denominator because you don't need a common denominator for this. And in this case, you can't simplify anything. The 2 and 4 are both in the numerator. They cannot be simplified. Has to be a numerator with a denominator. So you just get 8/21.